Hello, welcome to our follow-along review for our prereq for calculus topics for the test. So be sure that you have your calculator, access to the unit circle, pencil, and of course paper to work on these problems as you follow along with the review. This is not reteaching, this is reviewing. So if there's a topic that you don't understand, I recommend you go back to either the assignment and or the video for that topic. Throughout this follow-along review, you will be pausing the video to work on the problems and then pressing play in order to check the work to see how you're doing. This follows pretty much exactly to the test that you will see. All the questions are not exactly the same, but they're very similar. So if you do well here, then you should do just fine on the test. So let's get started. First, we want to find the slope between these 2 points. So please pause the video here and work it out. Work it out. The slope here is 4. For this next problem, we need to find the equation of a line. On your test, you'll be asked to do this twice, and one will have to be written in point-slope form, one in slope-intercept form. So what I'll have you do here is, when you find the equation of this line with these parameters, write it in both point-slope form and slope-intercept form. So go ahead and pause the video to work that out. So we've correctly written in point-slope form. I think this one's easier. When you're literally given a point and a slope, it's very easy to write in point-slope. So it's always the opposite. This is the opposite of the y value. This is the opposite of the x value here. And then our m, our slope, is out front. So this is point-slope form. In order to get in slope-intercept form, which is y equals, we have to solve for y, get y by itself. So we distributed here and then added this 1 to both sides to get slope-intercept form. The other thing that you'll be asked is talking about parallel lines. Just remember that parallel lines have the same slope. Okay, we also reviewed horizontal and vertical lines. So go ahead and sketch each one of each here. And you do not have to have a really nice coordinate grid. Just go ahead and sketch one out and sketch these 2 lines. Go ahead and pause the video to do that. Y equals -6 is a horizontal line. Remember we talked about Hoy Vux, so H-O-Y. Horizontal, 0 slope, the slope is 0, and it's of the form y equals. So this is a horizontal line passing through y is -6. X equals 8 is a vertical line passing through x equals 8. All the x coordinates are 8 anywhere on that line, and that is the Vux. This is just a little word, phrase to help you remember. Vertical line has an undefined slope, and it's of the form x equals. So if this helps you, great. That helped me learn it a while back as well. And just as a reminder, a horizontal line is a function. It passes the vertical line test. However, a vertical line isn't. It literally does not pass the vertical line test. So this is actually called a relation here, and this one can be is a relation and a function. All right, still along the same line of graphs, we are going to have to find the domain and range and write them in interval notation. And so if you recall, interval notation, it looks something like an interval. So it goes from one number to another. Sometimes one of those numbers is infinity. We can have open or closed brackets depending on if we actually hit that number or not. So recall that the domain goes from left to right. If you're looking at a graph, it is the x values, any x value that gets taken on. And the range, you look from down to up. It is literally the vertical range, and it is what your y values take on. So go ahead and pause the video to find the domain and range in interval notation. Our domain is the interval from -4 inclusive to 3 non-inclusive, meaning we take the leftmost x value we take on is -4. I sketched that here. We actually take on that value, so it's in brackets. And then the rightmost value that we take on, x value, is x equals 3 right here, but we don't take it on because it's an open circle there. Our range, if we're looking from down to up, the y values we take on, we range from -5 all the way down here up to 5, but those values are not actually taken on because there's open circles there, so we have open parentheses. So basically, if you see an open circle, that means you're going to have open like parentheses. You're not actually hitting that number. But if you are hitting it, it's not that we have to make some big closed dot here. We actually just take on that value with this point that we see here. So that's why the -4 is closed in the domain. And this is what interval notation looks like. We also studied function composition, which is when you have two functions and you compose them to create a new function. And when we do this, we are kind of inserting one function into the other. So what you need to do is compose these functions going both ways, finding f of g of x and g of f of x. Go ahead and pause the video to find both of those new functions. Okay, we have composed both of them. Here we put g of x into f of x here for x. So we had x squared minus 3 and then the plus 6. We combined the constants to get x squared plus 3. Number 2 is a little more complex because when we plugged f of x into g of x, we had to plug in x plus 6 in for x. So that had to get squared, and then we did a minus 3. So when we squared x plus 6, we did x plus 6 times x plus 6. We multiplied, or if you like to think about it as foiling it out, to get x squared plus 12x plus 36, and then we still had the minus 3. Combining our constants gives us our final quadratic trinomial. So in this case, order does matter, right? What you plug in the one that's literally plugged in inside for each, and be careful when you're asked to square something that's more than one term. You do have to FOIL or multiply it out. Another topic that we studied was exponents and negative and rational exponents as well. So go ahead and pause the video and simplify these four. Simplify means get it down to one single number. Here are the solutions to these four. I put the two main rules that we need to know. So this is the rule for a rational, aka a fraction, exponent. The denominator tells us the index, or what kind of root we're taking. So if it's a 2 down here, it's just a square root. We don't necessarily have to write the 2 there, but I just put it there just so you could see. And the numerator of that fractional exponent is what we end up raising it to at the end. So that's 1, 2, and 3. And then the rule for number 4, when you have a negative exponent, here's our rule, it flips and the value ends up going in the denominator, and it's a positive exponent. So if we can see for number 1, raising something to the 1/2 following this rule means we take its square root and then don't do anything to it, right? Raise it to the first. So taking something to the 1/2 power just means the square root using this rule. So again, in number 2, we took the cube root, since that was the denominator, and then we took the cube root of 8, which is 2, raised it to the 4th and got 16. We did a similar thing in number 3. In number 4, we had a negative exponent, and so we flipped it. It became positive, and our answer is 1/9. Just FYI, you are not going to get negative answers out when you raise something to any type of power. Even if you raise something to a negative power, it's still a positive answer. Next, kind of on the flip side of exponents, we dealt with logs. So go ahead and pause the video and simplify these 4 logs. All right, the 4 solutions are here. I did write up here, I don't want this to confuse anybody, but this is going from logarithmic form to exponential form. Basically, a log is an exponent. So I called that x. And we're looking for, what do we have to raise this base to get this value out here, the answer a. So we're looking for the exponent here. So I thought of it just with a question mark, not necessarily using x's, although I did see some of you on your homework, on the assignment, did use x's, which is great. But we want to think, what do we have to raise this bottom number to, this base, to get to this answer? So 3 to the what is 9. So this answer is just 2. Same with number 2, that one's pretty simple. Numbers 3 and 4 use rules for rational and negative exponents. So 125 to the what gives us 5, 1/3, since it's a cube root. 5 is a cube root. And then for number 4, 9 to the what gives us 1/81. Well, since 9 squared gives us 81, 9 to the negative second gives us 1/81. So the answer is -2. So when you're simplifying logs, logs are exponents. So your final answer is just a single number. It is what the exponent is. Okay, moving on to the last topic, which is the unit circle. So make sure that you have your unit circle to write down each exact value. Go ahead and pause the video to find these 4 values. If it's undefined, you can write UND. None of these four were too difficult, I don't think, but you do have to remember that the cosine is the x coordinate or x value. The sine is the y coordinate or y value at that angle on the unit circle, and the tangent is y divided by x. So cosine and sine will always give you exact values out, but since the tangent is a fraction, and actually so is like the other three, but we didn't deal with any of those. Since the tangent's a fraction, you have the possibility of it being undefined. So I want to take a look at 1 and 4 and explore the difference. At pi, and I wrote this wrong, I'm sorry. The x value should be -1, my bad. There. At pi, the y value is 0 and the cosine's -1. And therefore 0 over anything, so long as it's not 0, is 0. That's your answer. Don't write it as a fraction, it's 0. In number 4, at pi over 2, our y value is +1, but our x value is 0. We cannot divide by 0, therefore our answer is undefined. So that's the difference. The tangent is undefined at 2 spots on the unit circle. You should definitely find them because I will be asking you about that on the test. The last thing that we're going to do today is convert between degrees and radians. And go ahead and pause the video to convert from here radians to degrees and here from degrees to radians. In order to convert from degrees to radians or radians to degrees, you want to multiply by this unit, which is just 1, which is either 180 degrees over pi or pi over 180 degrees. Note on your unit circle that's the same location, so it's okay to multiply by this. This is just a large fraction that equals 1. So basically, if you want to write in degrees, you want the pi's to cancel out, so you want those to be, the pi on the bottom here. That's how I remember. Then we can cross cancel, so the pi's cancel, the 180 and 5 can both be divided by 5, and therefore we get 72 degrees when we multiply straight across the top and bottom. So we'll get 72 degrees. And that makes sense because 2 pi over 5, this is not quite half, right? 2.5 out of 5 would be half, and half a pi is 90 degrees. All right, so down here, writing 250 degrees in radians, we multiply again by this unit, but this time we want the degrees to cancel because we want it in radians, and so the degrees go down here this time. So we want pi in our final answer, and we can cancel the degrees, just like we could cancel the pi's, and we can divide both top and bottom here by 10 by canceling the zeros. 25 and 18 don't have any other common factors besides 1, so our final answer is 25 pi over 18. So there you have it. If you've made it through this review decently well and you feel okay, then go ahead and start the test. If you feel like you had to review something, please review those things. Take a look at the feedback that I've given you for your assignments on Schoology, or feel free to ask me any questions before your test on Friday. Make sure that you take the test on Schoology by Friday at 11:59 p.m. because that's when it'll close. So make sure you start it at least by 11 p.m. on Friday. All right, take care, guys, and good luck.